Hi, this is a quick review of the Cobweb model, which was devised by Nicholas Caldor in the 1930s using Marshallian demand and supply curves. If you look at price one, if we start at price one where there's been let's say a harvest failure for raspberries or something, so the price is quite high. Now, this encourages people to supply a lot more for the following year. So a high price of raspberries, the farmers shift over from maybe strawberry production or whatever berry production and move into raspberry production, maybe till the land for in preparation. And this encourages a massive increase in supply, which the following year or the following season drops the price down to P2. Now this in turn, given the demand, given the supply conditions, encourages farmers to produce less raspberries the following year, which pushes up their price up to P3, which encourages more to come back in the market, which encourages the price to drop, and you keep on going in a spiraling convergence onto equilibrium. And it's quite an interesting model, but what it's assuming is that the producers are looking at last year's prices to govern what they'll do the following year. It's also, how this is affected depends on how you draw the demand and supply diagrams. So in this case, price elasticity of demand is more elastic than supply, and when you draw it like that, you'll get a convergence. On the other hand, you'll get a divergence if you have different demand and supply conditions. So for example, if the price elasticity of supply is more elastic than demand, we have a divergence away from equilibrium. So starting at a price such as P1, P1 is slightly above what would be the market equilibrium otherwise, and this causes an increase in supply, which during that season of consumption, the price drops down to P2, which sends a signal to producers to produce less, which then forces the price up to P3 because demand stays the same, which then encourages more supply coming onto the market the following year and so on. But in this case, we've got a divergence away from equilibrium. Now, if we draw the elasticities in such a way that you end up going round and round in a box, that is also very possible. So mathematically and diagrammatically, you can create convergence cases or divergence cases, or one that just goes round and round and round and doesn't quite enter equilibrium at all. And it's a great little model to think about, but the big problem with it, critically, is that it's assuming people are adaptive in their expectations. They're always looking backwards to what last season's price was, rather than looking forwards to what demand may be, and also rationally minded, thinking about, well, if we create a lot more raspberries for the market, that's obviously going to push the price down. So what economists have found and psychologists have found is that people do adjust to these kind of markets and converge, as it were, more onto equilibrium. From a different point of view, we don't worry about equilibrium, we just worry about the process. Prices are fluctuating all the time. We can hedge or insure or take futures contracts for the future. And this is what the commodities issue is all about in issue 4 of the economic circle, that we can converge onto equilibria, but the equilibria are always changing. So therefore, traders are always looking for ways around the potentiality for divergence or temporary convergences, for example, using different derivatives and options and insurance packages, and that's because they've got an incentive to do this. So the likelihood of a divergence is extremely unlikely, whereas convergence is more likely. But just remember that, in the real world, we don't actually come across demand and supply curves. These are mathematical or graphical representations to enable us to see what could be going on. But in the real world, traders have a huge incentive to converge onto something that's going to maximize their profits, minimize their costs. And that's true for consumers, maximize their preferences as well as producers. Okay, thanks for listening, guys.